And the way this is going to work is Sam is going to talk for 15 minutes, then Ben is going to talk for 15 minutes, and then the jury and yourselves are going to interrogate both Sam and Ben, and then we'll hopefully come to a conclusion.
So I'm going to argue what we need as standards in the cloud. My name's Sam Johnston. I'm from Google in Zurich, and this is predominantly my personal opinion. Now, most of that should match up with what Google thinks, but I'm not going to tell you which parts. So we'll just have to assume that it's my personal opinion and don't go saying, Google said X. So what are standards first? And a standard is an established norm or requirement. So we're talking about formats, things like Word document, protocols, things like HTTP, languages like Perl, and hardware like PCI and AGP and so on. So what I'd like to talk about more so than standards in general is open standards. So the first thing we need to do is work out what open standards are. For that, we go and have a look at Wikipedia. There's 15 definitions. So we have a spectrum of openness going from closed standards or proprietary standards, like the Word document format, which has afforded Microsoft a multi-decade monopoly, and it's still not fixed, despite the fact that we've got OOXML, which was recently rubber-stamped by ISO. The version that is actually implemented is transitional rather than the strict version, which was the standard that was actually approved. So what about OVF? This is probably the best analogy that I can find in the cloud. This is a descriptor format for virtual machines. Are we going to end up with a Word document of the cloud? I don't really take a position on that. That's a question more so than a statement. But I think it's something that we need to be cognizant of is we don't want to repeat what's happened previously by getting locked into one format. So at the other end of the spectrum, we've got free and open standards. There's a bunch called the Digital Standards Organization, which you can find at digistand.org, and they have a number of requirements for free and open standards. One of which is that it has to be free from vendor capture at all stages of its life cycle. It needs to be maintained by a non-profit. It needs to have a freely available specification which documents the standard in all its details. There needs to be royalty-free licenses available for all of the patents that might be present for that standard. And there needs to be no limitation on reuse of the standard. So that's the other end. Now, what I'm arguing then is what we need are open standards in the cloud rather than just any old standard. So what's open? Well, if we look at free software, that's at one end of the spectrum, and at the other end of the spectrum we've got proprietary software, and in the middle we've come up with this thing called open source. There's a well-defined definition, the open source definition, which is maintained by the Open Source Initiative, which you all know about, and if you don't, you can find out more at opensource.org. This finds a balance between freedom and being able to use open source software in business. So it creates a whole lot of business models that people can use to make money, for example, consulting and so on. It also provides a litmus test for us to say categorically what is and what is not open source. So how do we do that then for cloud? What is open cloud? So back in early 2009, there was a large computer company created a document called the Open Cloud Manifesto. This resulted in a whole bunch of cloud washing, a whole bunch of open washing, eventually some discussions, and the formation of a thing called the Open Cloud Initiative, which you can read about at opencloudinitiative.org. What we all agreed was that we need to have open standards. But more than that, we need to define what open means, because there's 15 different definitions. So we say, okay, we need to have this, the formats and interfaces documented. We need to have copyrights available for the specifications. We need to have any patents. If there are patents, they need to be available on a royalty-free basis. Any trademarks that are used, so for example, the Rackspace Cloud API or the Amazon EC2 API might run into problems there with trademarks. And then we also need to have multiple interoperable implementations, at least one of which is open source. So if you were to ask Simon Wardley, if you have a system and you have a specification, let's say that you've got Office and it talks OpenOffice XML, and there's a specification which is about that deep, you either buy Office or you have to implement it from scratch yourself. So that's not really, it doesn't really give you any freedom there because most people aren't going to be able to implement Office. What about the process? Now, a lot of people, when they define open standards, they talk about the process. So they want it to have an open process where any interested party can involve themselves in the design. Now, I'm going to give a special shout out here to the DMTF, who claim openness while charging $12,000 or thereabouts for a vote. I'm more excited about things like the IETF, which is why I was involved in the OGF, which is modelled after that, which allows anybody to join and contribute to the standards development process. A lot of cloud standards are actually developed by single vendors, which is another. There's basically a closed process there. As an individual outside of that vendor, you can't get involved. Okay, so what's open cloud? We decided that there's two things that we care about. One is open interfaces. This is deliberately vague because we're talking about protocols like AtomPub and interfaces like and APIs like JClouds. The other thing we need is open formats. So in this case, something like Open Document would be considered an open format. If you have open interfaces and open formats, you have open cloud. Take, for example, an online word processor. If you can do a get, in this case, slash document.odt, that is an open protocol, HTTP in this case, and you're getting an open format, so your data is free. You can retrieve your data. So an example of this is the Google Docs List API. Other nice-to-haves are open source, so for example, OpenStack, and open data. And when I say open data, I'm talking about Creative Commons licensed data, so for example, OpenStreetMap and so on, as distinct from actually being able to access your own data. Now, if you're a company, you don't want your sales, your customer database, your accounting system to be available under an open license. So at Google, we have a thing called Data Liberation, the Data Liberation Front, which you can read about at dataliberation.org. And this basically allows you to access all of the data that you've got stored in the Google Cloud via open APIs. Okay, so if you have open interfaces and open formats and open source and open data, this is what I'd call free cloud. Free as in freedom. The best example I can think of is Wikipedia. But there's another problem. It's not just about openness. We have a paradox of choice. So if we have N implementations, currently we've got N+1 standards or thereabouts. Too many standards. So to solve that, what we've come up with is there's some people who've written some software like Delta Cloud, JClouds, and Fog, which are adapters. Now, the problem that I have, which is possibly more theoretical than practical, is that there's an impedance mismatch, to use an electronics engineering term, and there's also potential performance problems. So the way I see this is it's a very important transitional tool to get us to where we need to be. So now I'm going to further refine the question to say what we need is an open cloud standard. If we look at the internet, we have a standard there which is TCP/IP, which has beaten out IPX, SPX, and a bunch of other arcane protocols to become the king of the roost on the internet. For the web, we have HTML over HTTP. And for the cloud, I think we can build on top of HTTP, thus standing on the shoulders of giants and using the HTTP as the uniform interface. We need to deviate from HTTP as little as possible, and some people would call this a web-oriented architecture or a resource-oriented architecture. Basically, it means using HTTP as the design is intended. So no envelopes, certainly nothing like SOAP. What that means is to put the metadata, so things like attributes, linking between resources, and categorization of resources into the headers where they belong, keeping the payload clean for various MIME types for things like text documents, source codes, virtual machines, and queued objects, and so on. This means that as a developer, you can interact with the cloud using simple tools like curl. It's also seeing the cloud as a cloud operating system with many components which are loosely coupled. It's the Unix philosophy of doing one thing well. And so what we're doing here is we're actually designing a system such that any one component or multiple components can fail. Where previously we put unreliable software on reliable hardware, we're now putting reliable software on unreliable hardware. And for this, we need standards. Now, there's another problem we've got, is standards proliferation. If we're looking at what we're dealing with today, most of the discussion about cloud is around the infrastructure layer, we haven't even really started talking about standards for platforms. Infrastructure is very simple in comparison to having a standard for App Engine versus a standard for Azure. And then when you get to applications, you need a standard for each different type of application, be it a CRM or a sales application or email. And basically that's how long is a piece of string. So why do we want standards? The main reason is we want freedom. That's good for users because it avoids vendor lock-in. It also guarantees interoperability, it guarantees portability, and it guarantees manageability. It's also good for providers because it creates a market. Where we have a market, where we have a commodity, we've got commoditization, we have unfettered competition, and ultimately we have utility computing. Some people would say that that is the same as cloud computing. So if we have islands of standards, for example, if we have storage services and we have some of them using the Rackspace Cloud API, some of them are using the Amazon S3 APIs, then we have islands, and if you target one of those APIs, you can only access services from that island. Whereas if they have a standard API, or if you have an adapter, you can access any service from any provider, and therefore you can target the best cost, you can target the right location, the performance, whatever it is that you require for your application, you can optimize. So if we look at a quick case study, I've got 4 minutes or something left, so we'll quickly have a look at railway gauges down under. So in 1848, there was a standard proposed. It was about 1.5 meters is the gauge between railway lines. And all 3 colonies at the time agreed. So what could possibly go wrong? Some guy came along, and in 1851, they went Irish. So they went for 1600, which was not 1435, and the other 2 colonies ended up following. Except that then a new guy came in, and he introduced the standard again, which is 1435. So now we ended up with 2 different competing standards for railway gauges. In 1865, another state introduced narrow gauge, so now we ended up with standard narrow and Irish gauge for the railway systems, which meant the trains had to stop at borders and transfer payloads and so on, which was obviously inefficient. This is what some of the railway tracks look like, where you'd have changeover points, triple gauge. Another example is electricity. This is relatively simple. We have voltage and frequency are the 2 main variables, but we still have many combinations. So here in the US, we have 110 volts at 60 hertz. Where I'm from, we have 240 plus or minus at 50 hertz, not to mention the various plugs that we've got. So one of the things that I think would be an interesting area for standardization would be to come up with an electron for the cloud, which is the smallest workload possible for the cloud. If you look at the way the cell processor works, which is what drives the PlayStation 3, it has things called appulets, which are basically code plus data, and they're processed at a very small unit. So if we can have a cloud service which would consume these, it would be much more granular than, for example, having a virtual machine or even a platform. So another case study to look at is internet standards. These were defined in advance by academics and individuals working at the IETF. So we've got things like HTTP, FTP, and BitTorrent. All of these standards are popular today, with perhaps the exception of FTP. They all have certain areas of specialization. Ultimately, what happens is that open wins, eventually. So it's not a case of whether or not we need standards, it's a case of when we'll have them. So what are the next steps? There's certainly no point shouting at the cloud, because it's here and it's here to stay. So what we need to do as the open source community is find a way to stay relevant. The best way to stay relevant is to write code, to consume services, and to give feedback. If you want to find out more about the Open Cloud Initiative, there's opencloudinitiative.org. And if you want to get in touch with me, I'm at SamJ on Twitter. My relatively neglected blog is samj.net, and I'm sj@google.com. So enjoy OSCON. That leaves a minute.
Okay, can we reset the timer? Now we have a legend in the cloud, Benjamin Black, to give the argument that what we don't need are standards in the cloud.
Well, thank you for that understated introduction. So I'm here to talk about why we don't need standards in the cloud, or more specifically, why it doesn't matter what we think about standards in the cloud. Because if a standard falls in the forest and there is nobody there to adopt it, is it still a standard? There's an enormous proliferation of so-called cloud standards, challenging the very definition of cloud. And so I actually happen to have some video from the future of the final cloud standardization debate. Watch carefully. You can actually see the standardization process at work here. Right? This is obviously an effective and experienced design committee, and here's an important decision. That's it. That's right. The cloud standards are now defined. So, my name is Benjamin Black, and I have no standards. So let's talk about something interesting instead, which is technology adoption, because standards do not matter. Okay? This is a customer-centric view of things. We can all speculate however we would like about the value of standards now or in the future or what those standards might look like. But ultimately, we must solve customer problems or we are irrelevant. So I argue that this is the only way we can approach this and come to any sort of reasonable answer. So why do customers adopt a technology? Well, the first reason that they do that is utility, right? It solves a problem that they have. This is the first order problem. Doesn't matter how we think about standards or interop or any of these other things. If you have not solved the customer problem, it is useless. So once we have established utility, interoperability becomes interesting, right? Can I combine vendors and products to solve my problems? Right? I've already got the utility part down. My problem is solved. I'd like to improve how that is actually accomplished. And then finally, independence, which means can I be totally free of vendor lock-in? Because, of course, it's totally possible for a couple of vendors to team up and agree to what they're actually implementing, and now you have interop, but you have no freedom whatsoever, right? And so utility, interoperability, independence, right? This is our stack. But these are not all equal. This is a hierarchy of needs. We can't achieve one of the higher level ones without having achieved the lower level ones. So, utility looms large. Doesn't matter what else we do. If we have not met the customer requirements, we have failed. Interoperability. This is valuable, but significantly less so than utility. And finally, independence. And in many situations, all that matters is utility, right? Some problems don't even need to go past utility, which may seem strange, but we see it in practice, right? Oracle SQL and SQL Server SQL and Sybase SQL and this SQL and that SQL, everyone's got a different notion of what SQL is, but it turns out people use it anyway. And the fact that there is no meaningful interop, that there is in fact an army of layers on top of these things so that you don't have to worry about the interop, things like active record or whatever other ORM or abstraction layer you put on top of them. Those things exist exactly because interop does not matter in this space. So utility trumps everything here. But there are some problems that you can't achieve utility without also achieving interop. And TCP/IP would be a great example of that. Now, interestingly enough, TCP/IP was not formed from whole cloth and released onto the world. You may notice in certain code or certain documentation that you read that it says not IP, but IPv4. That is no accident. It was an evolving process that emerged from academic research and copious actual operational experience with them. That is critical, because what it did was make sure that by the time there was anything that was called IPv4 as a, quote, standard, there were already numerous interoperable, well-understood, well-tested, battle-hardened implementations of it, right? You don't have a standard emerge with a bunch of implementations with those characteristics unless that standard is merely a representation of what is already the case. So, what is the cycle for adoption, given that we've looked at this as utility, interoperability, independence? How do we actually get to these points? So the first thing is disruption. Something new arrives, and that new thing has massive utility. Utility so extreme that it doesn't matter what else is wrong with it. People will adopt it, right? And we can expect a lot of imperfections, but massive utility to go with our lots of imperfections. And that drives rapid adoption by definition. If you don't have rapid adoption, you do not have something disruptive. So secondly, competition. This is what emerges next. And this is all about exploration, right? We've got this amazingly disruptive thing that has arrived. It's like nothing anyone has seen before. We don't really know the full scope of its impact. We want to try and get our arms around it. We explore. This is where the competition comes in. We can expect this explosion of variety. And our goal is always discovery. What is this space all about? How do we actually make best use of it? Okay? And this is not just discovery of solutions. This is discovery of the complete problem. So, in that phase, we get many so-called standards. And we certainly saw this in the networking space. I imagine that people with expertise in other areas have similar things on their mind. So, many standards, IPX, SNA, DECnet, right? And also IP off to the side, right? These things are all standards, meaning that there is, in fact, no standard. But the seeds of interop are sown. And what I mean by that is that we have all of these so-called standards striving to achieve some level of dominance. And ultimately, they recognize, the people behind these things recognize, that in order to make progress, they must begin cooperation, right? And what is interop if not cooperation? So we are currently in this stage for the cloud. We don't know what it looks like. We have a proliferation of things that are called standards. We have all kinds of people adopting all kinds of things. And we have a lot of folks discussing the need for interop, for cooperation. No one actually knows what that will look like, because it's not as simple as saying we're all going to use the same API for something, because we don't know what that API needs to look like, right? We know what the API already looks like. We know what our first try was, but we don't know where that needs to go. And finally, and we are not here yet, if that wasn't obvious, we get to maturation, okay? This is a formalization of the things that we discovered in the previous stage. So, our itch having been scratched, we turn to less pressing matters. Independence. We may not ever need to get here for certain things. It's important to a lot of people in a lot of different situations, but not all. So, successful standards formalize what is already true. I cannot think of a case in which something that had not been implemented was standardized and succeeded. But I can think of a lot of counter-arguments to that, a lot of counter-examples. WS star being one of the most spectacular in this space. So standards are actually side effects. We have something else that we're trying to solve, and a standard shows up unbidden, right, of successful technology. So there are no successful standards absent successful implementations, and all successful standards are de facto standards. So we're calling something a standard because everyone already uses it. It is a de facto standard. We then give it the imprimatur of a standards organization. And we say, thus, a standard is born from whole cloth. But amazingly, we have all of these implementations that interoperate and are well-tested. Right? That is the path that we are on. We just don't know what it looks like yet. But there is no such thing as a free lunch. As the degree of standardization increases, the rate of innovation, the rate of change necessarily decreases, because you can't be constantly changing everything everywhere and converging on any sort of agreement on what it is that you're building. Interop, in particular, suffers horribly when the rate of innovation remains high. So up at the top, we have utility. As we drop down in our rate of innovation, we get to interoperability, and ultimately we have this independence wherein we are almost completely static. Great place to be for technology adoption if you want no risk. Terrible place to be if you're trying to build something interesting. In particular, if you're trying to build something interesting in a poorly understood space like the cloud. So the innovation, of course, doesn't disappear. It simply moves elsewhere. It may be up the stack, it may be down the stack, it may be off into a completely different sort of space. But we certainly lose it from the environment that has been standardized. So if you standardize too soon, and you can lock to the wrong thing, right? You decide, okay, this is it, guys. It works well enough. We're just going to bless it. This is the way. But then we actually do the learning. We actually do that exploration, and we discover that we got it horribly wrong. And now we essentially have to just live with it, or we have to break our standard. Neither one of those is particularly attractive. But it's unclear that it's even possible to standardize too late. Patience is absolutely a virtue when it comes to deciding to standardize. But in all this, we've actually missed an important question. What do we even mean by standard, right? There's this thing called a standard. There's a standard specification. There are these standard committees. So what's a standard? It's what everybody uses, full stop. We don't need 14 Wikipedia definitions. Utility and disruption gets you a standard. It's what everybody uses. Standard specification. Well, that's what someone hopes you'll use. Whether or not there are implementations, whether or not there are adoptions, I can go and publish a standard specification for anything I like and claim that there's now a standard out there for it. Does not make it so. So interoperability goes along with the standard specification. If everyone does this thing, then we have interop. Great. And finally, we have the least important in this whole model, the standard committee, the legislative branch of our engineering and innovation organization. Okay? That's where we get our independence of, or independence from, so-called vendor interference. How dare they implement things and then look to actually have some agreement on what those standards are. Okay? So what are they concerned with? And this is going to look familiar to some folks. Well, they're concerned with things like this. These are very important to standard committees. They tend to be not so important to people who are actually trying to get things done. And for special bonuses with standard committees, we get these things. Not so attractive to folks. So if you do not achieve utility, customers will not bother because they want their problem solved, and that seems pretty reasonable to me. Standard committees do not build anything. Okay? The only way we can discover the right standards is by building and exploring. That's the phase we're in now. We should embrace it. To discover the right standards, we must eschew standards. So go do.
Very much. So we've heard the arguments for and against standards. Do any members of our jury have any comments they want to make? Any questions you wish to ask?
So, I don't know if the mic is okay. For the position against standards, we've talked a little bit about TCP, IP. We've talked about HTTP. Do you think the web would look the same or different if it was under the same royalty terms as Amazon's API?
That's actually an independent question of what I'm answering, which is, does HTTP meet the utility requirement, right? And it does. Did something commercial meet it before then? No, it did not. Would the web look the same? I don't know. But I don't actually think we know what the cloud computing world will look like. So were there things prior to HTTP that were totally commercial and did kind of similar stuff? You bet, right? They lost. So I'm not arguing against anything like simple and open doesn't win. Totally does. Over what time scale? A pretty long one. Because over the short time scale, you're totally dominated by commercial entities.
Well, I guess what I'm taking issue then is, you know, the statement was made early along that standards don't matter. And, you know, I think certainly as we look to see how this is going to play out, I think that's an interesting statement to work
So I actually made a slightly different statement, which is that what we think about standards doesn't matter.
So standards do matter then is what you're saying?
No. I'm saying it doesn't matter what we think about them. They will happen on their own terms if they are required and to the level that they are required. Because, for example, in the SQL world, there's no standardization, really. But the utility is so high and the requirements for interop and independence are so low that works, right? But in other spaces, the requirements for interop and independence are very high. And so things that do not deliver those die off. And the end result is agreement on what things are. That's a standard.
So this is scary because I understand you and agree with you, so that scares me.
I can try again if you like.
There's something wrong. So I get what you're saying, and I agree that it's the utility trumps all. The SQL example was great. So Sam, I didn't get that kind of Twitter for me. You know, I'm a simple guy. I got, for me, right or wrong, what you were saying, kind of my Twitter version of that long 15 minutes. I mean, I didn't get your Twitter version of, like, why. I did get his. And, like, give me that short, you know, or why is he wrong? Give me the short version of why he's wrong. Because for me, whether it makes sense for anybody else, I get it.
Right. To be honest, I don't completely disagree with him. I do think that, you know, I mean, I've been involved in a standardization process, and the comment about looking at what exists and what's been implemented is interesting. And we did, you know, you go to a lot of effort to make sure that you can be extensible. And if you look at something like the Amazon API, it's infinitely extensible. And then maybe we'll come back later on and say, okay, well, these are the things that people used. We'll lock those down. But if you don't have, let's take the SQL example again. If we look at a storage service, the simple primitives like to put a document or a file and retrieve a document or a file or delete it, you know, the basic HTTP verbs, provide a level of interoperability, just like ANSI SQL does, which allows you to have a marketplace already. Now, the advanced functionality, things which are implementation specific, like ACL security, logging, monitoring, all that kind of stuff, can come later. And I don't really see a problem with that. But if you are confined to, because of the software that you write, you decide you're going to write to the Rackspace Cloud Files API, or you decide to write to the Amazon S3 API, and then you've got Amazon and possibly Google, depending on whether or not you implement the subtle differences. It restricts you, which means that you've got less providers to choose from, which means ultimately you have less choice, you pay more. So if everyone's on the same page talking the same language, then it's better for the users.
Ben, do you have any response to that?
Yes, I do. I would say a couple of things. One is that here's the core, and then we have a bunch of totally incompatible vendor extensions is exactly how we get to the SQL space, and it makes interop incredibly hard. The second piece that I would bring up is that we are focusing on what we do right now because that's all we have, but we don't actually know what it needs to look like. And so when we say, hey, there's a simple storage get put API, sure, that's true. But if you look at any of the emerging storage standardization efforts, they have huge sets of mappings of saying, oh, well, you want an iSCSI LUN, or you want FCOE, or whatever it is that you want. We have to map in and out of all those things. Why? Because it turns out in a lot of spaces, there's no one best tool for the job, and you use a bunch of different things. All of them are called standards. It makes the term almost meaningless, right? And so In this space, I expect that for a while, possibly permanently in a number of areas, that will still be the case.
Okay, we have a question over from the audience.
Hey guys, one of the things that struck me in the conversation so far is that the argument hasn't really been about standards good or bad. It's been about a priori standards versus ad hoc or post facto standards. It's the nature of how standards emerge that is being debated. Surely there is a class of environment where the cost of experimentation is too high to find a market adopts the standard outcome, right? In a digital world, it's very easy to say, let the market adopt the standard. In an analog world where there are physical things that have to be built to standards, then experimentation can get quite expensive and will not necessarily get you to have market outcomes. Then you start having, Henry Ford, like if I asked, the customers what they wanted, they'd have said faster horses. So there are times when setting the standard is necessarily disruptive and not post facto adoption because you've got to lead.
Sure, and that goes into area one, disruption, right? Disruption by its nature means customers did not anticipate this is what they needed or they probably would have asked for it, right? But once it arrives, their whole worldview is changed. They're permanently altered. They can no longer not see the car in the Henry Ford case, right? And so in the cloud case, we have exactly the same thing, right? Infrastructure as a service arrives, people realize, my gosh, this is exactly what I always wanted, to do all of these things that I never knew I needed to do. And so I am not advocating for going out and doing sort of democracy-based discovery of what people need. What I'm actually advocating is you build stuff and get people to use it, and if it works, then you succeed. I think that's a pretty straightforward argument.
So I think I'm spinning my wheels mentally a bit here because I don't think either one of you necessarily put the question sharply enough into context with regard to the cloud question. And maybe that's because the cloud question is too big. John mentioned this morning, a great comment, it doesn't make sense to talk about security in the cloud. It only makes sense to talk about something like security for Google file system or for S3 to put it in some specific context, because otherwise it's just kind of masturbatory. We're talking here about standards for the cloud, but maybe that question doesn't even really make any sense. Is what you're talking about equally applicable at all levels of the SPI stack, or do you not care about that, or is that of no interest to you, or what? You kind of hinted at this briefly by a couple of your remarks, and you didn't say anything about it at all. So in essence, we're having a conversation about standards in the abstract almost.
I feel like I've failed if you think that I haven't said anything about it at all. That's exactly what I've been talking about, is that different components of this will evolve at different rates in different ways. And so when I give a specific example, like in storage, there are so many different ways to interact with storage, we can expect a lot of different things that are called storage that are different standards that people use. But in other areas, that may not be required. So for example, spin up and spin down for virtual machines is a pretty straightforward thing and probably won't require a lot of standards, but who knows, right? We haven't even begun to discover what it really takes to operate in these things in these large federated systems. How do we create hierarchies of these things? They're simply not addressed in any of the existing things that are called standards, and they will have to be.
Okay, we have one question over here.
Question for Benjamin Black. Hope it's on. Benjamin, अगर हम दोनों एक दूसरे से बात नहीं कर पाएंगे एक ही भाषा में.
What's that?
See, we both need to have the same language to talk with each other.
Sure.
So unless there are some standards, we won't be able to innovate. English is a standard we are assuming. And on top of that, we are innovating. So your chart about you need standards. When standards are established, innovation goes down. It's not correct.
I believe it is depending on where you are in the model. Because when something disruptive emerges, nobody speaks that language. And so the argument that it can't emerge unless everyone speaks the same language is exactly how nothing happens, right? EC2 does not exist if everyone insists that it work the way that everything did before, that it speak the same language as everything did before. Because clearly it's not sufficient to say it runs on HTTP, it's RESTful, or it's XML, or whatever. Like, these are not meaningful statements in terms of establishing useful semantics for a standard, right? They may be necessary. I'm leaving that question open, but they are definitely not sufficient.
Okay, just to clarify on one point there is a distinction between, as something becomes a standard, obviously the rate of innovation of it declines, but what gets built on top of it accelerates.
Right, which is that the
becomes.
Innovation moves elsewhere, right? That was
Bingo.
exactly what I'm saying, is that it moves somewhere else.
Okay, we have our final question before the jury have to decide. James Urquhart.
So this is really fascinating because I think it makes a case pretty strongly for something that I've believed for some time, which is really it's got to start with an innovation that comes from a set of innovations from a lot of different places that come from relatively small individual or groups of people who kind of, their brain power kind of creates the innovation, and then the market begins to absorb it and determine. So doesn't this state pretty cleanly that you can't build an innovation on something like open source, which is a community-based effort, but instead open source is going to follow the innovation and then begin that trip of beginning to standardize the thing that it is emulating. Is that a fair statement?
That's certainly been the case in a lot of projects, a lot of interesting projects. It's not always the case. I would point at things like the Apache web server as things that were not of that sort, that were just always open source.
There were web servers before Apache built their web server.
Sure, it was NCSA, right? Which is why it's called Apache. I mean, the point that I'm making there is not that I disagree. I actually mostly agree. I'm just pointing out that it's not always the case.
Okay, well, first of all, thank you, Sam. Thank you, Ben. That was a fantastic discussion. Please put your hands together for Sam, Ben. But before you leave the stage, it's time for the jury to decide. Do you think what we need are standards in the cloud? Are you with Sam, or are you against the argument and with Ben?
So in the business domain that I work in insurance, there are a number of standards. There's things called Origo and Accord and all kinds of nasty things like that. And they've all attempted to standardize things that aren't yet standards. And that hasn't worked out too well. I'm the guy who's a big fan of deferred decision making, and by my nature, I'm very skeptical of a priori efforts. So for all of those reasons, I found Benjamin's arguments more convincing.
One for Ben.
Well, it's interesting because, generally speaking, when it comes to technology, I take a very laissez-faire attitude. Let the market decide. Which would seem to certainly favor Ben's position in terms of what we actually think about standards. Doesn't matter. I guess the difficulty that I have with that argument is that it seems to suppose that this is all somehow Calvinistically predetermined, and that the fates are kind of set and there's really nothing we can do about it, and that they're just going to play out. I don't think there's any really disputing the fact, as Mark said, that a priori standards are generally destined to fail, but neither do I think we have to set ourselves or make ourselves comfortable with a fate that says, well, whatever people's using is just, and whatever people have decided to settle on is good enough, and we just don't need standards. In other words, the SQL example, which keeps coming up, to me is not encouraging. That's not a positive statement. Nor is the examples that we've seen from a Google or from a Microsoft Office format perspective. I mean, these are not positive customer outcomes. So,
is that a yes for Ben?
That is I believe that Sam in parts is right.
So that's 1-1. Pat.
On the sheer basis of the statement that standards are side-affecting behavior of successful technology, I'll go Ben.
Oh, 2-1.
And I've got to go with Ben. I just think that the utility trumps all. That if what you're saying is worrying about it, or that standards don't matter in the sense that they're just going to happen. if that's your argument, I just totally agree.
So the final conclusion is we don't need standards in the cloud. Well, not yet. They will develop anyway. Please thank Sam and Ben. And the other lesson to learn is never argue with the legend of cloud that is Benjamin Black.